if this thing's not written in standard form, what we have to do is rewrite it in standard form. And just like our circle with an ellipse, we have to complete the square twice, just like we did with our circle. So we're going to be completing the square twice. But there's one extra step after that. After that, I have to divide by the constant value. Okay? And when we say that, when we look at our equation for these things, it's always equal to 1, and that's what I'm doing. I'm essentially going to take whatever number's over there by itself, and I'm going to divide by that number so I can turn it into a 1. Okay, so complete the square twice, and then divide by the constant. If we look at this first one is just meant to illustrate that last step of dividing by the constant, because completing the square is already done. When you think about this, if I were to take this off to the side in a thought bubble here, this is like a 4 times x minus 0 squared plus 8 times y minus 0 squared equals 32. And so really completing the square is already done. I already have perfect squares here. All I need to do is get a 1 on that side. So what I'm going to do is I'm going to divide by this number that's by itself, okay? 32 is the constant term because 32 is the value that's by itself. So I divide each side by 32, and it's just a matter of reducing each of these fractions. Right here, when I reduce this fraction, the 4 over 32, that reduces to a 1 over 8. So I get an x squared over 8. And then right here, when I reduce this fraction, I'm just dividing each. 8 divided by 32, that's going to reduce to a 1 over 4. So I just end up with a y squared over 4, and it's all equal to 1. Okay? Now this thing is written in standard form. And the last thing I always check here, just to make sure, is remember, my a value, my first denominator, has to be larger than my second denominator. And in this case, it is larger, which means this thing is written properly. So this is my standard form. Okay? And I'd be able to identify the center and the foci and all of that stuff from there. Okay? If I look at the next one, this time I'm actually going to complete the square twice first, all right? So the first thing I have to do is create space, so I subtract this 116 from each side. So I subtract the 116, I get x squared plus 8x with a little space. I've got a 5y squared plus 100y with a little bit of space equals a negative 116. And I go to complete the square here. The first part is easy. I can do that 8 divided by 2 and square it, and that's fine. The issue is this second part. Some of us are going to feel tempted to take this b value, divide it by 2, and square it. So get 50 and then square it. But the problem is I can't complete the square here because of this 5 that's out front. Remember, you can only complete the square if you have a 1 in front of your squared term. So before I can fill in these blanks, here's what I have to do. All right? Typically, we would just divide that off. The issue with dividing that is if I divide this by 5, I have to divide everything that's over here by 5. And we can see what kind of a headache that's going to create, especially for our x squared. So I don't want to divide. What I want to do instead is something similar to division that doesn't cause all those problems. I'm going to factor. Okay? So I'm going to factor out this 5, which is going to leave me with a y squared plus 20y with a little bit of space. Okay? So I get all the benefits of dividing without all the headaches that it causes, so I just factor it out. Okay? Now I can do b divided by 2 and square it. Over here, 8 divided by 2 is 4. 4 squared is a 16. Inside these parentheses, I do 20 divided by 2 and square it, so that gives me a 10 squared, which is 100. And now whatever I do to one side, I have to do to the other side, and this is where the real difficulty comes in for students. Right here, this is obvious. I added a 16 for that trinomial, so I have to add a 16 to the other side. But right here, what I actually added here was a 500, and that's what I have to add to the other side. See, it looks like I added a 100, but I didn't. And if I were to take this off to the side, let's think about what this really means. If I had a 5 times y squared plus 20y plus 100, it looks like I added 100, but keep in mind what this is really saying. I would distribute this. So look at the constant term that I actually end up with when I get a 5y squared plus 100y plus 500. And that's where I'm getting this 500 from. It might be a 100 inside the parentheses, but it's a 500 to the entire side of this equation, okay? So I added a 100 inside the parentheses, but I added 500 to that side of the equation. Now I can finish simplifying this. This is going to be an x plus 4 squared, plus this is going to be a 5 and then a y plus 10 squared. Over here, I add all these together. That's going to give me a 400. And now the last step that I look at here is dividing by the 400. I need a 1 over here, so I divide each side by the 400. And now essentially I have two fractions to reduce. Right here it's like there's a 1 out front, so I do 1 divided by 400, which is just a 1 over 400. So I leave this as an x plus 4 squared over 400. Plus, right here I'm essentially reducing this fraction. 5 over 400 is going to reduce to a 1 over 80, so it becomes y plus 10 squared over 80. Again, I'm just dividing each piece. It's my distributive property. Equals 1. And now my last thing that I check here before I finish up this problem is I make sure the first denominator is larger than the second denominator, which it is, which means this one is written in the appropriate format. So now it's in standard form. Okay? If I look at this last example, in this last one, again, I want to start off the same way. I'm going to create space. So I create space by subtracting the constant term. And now I'm just going to reorganize some things. So I've got a 4x squared minus the 24x with a little bit of space. I've got the plus y squared plus 4y with a little bit of space equals a negative 24. And now just like before, I have an issue here where one of my squared terms doesn't have a 1 in front of it, so I have to factor it out. And it's this guy right over here. I've got to factor out that 4. So I factor the 4 out. It gives me a 1x squared minus 6x with a little bit of space. Here, this one was okay the way it was. And now I complete the square. B divided by 2 and square it inside these parentheses, that gives me a 9. Over here, b divided by 2 and squared gives me a 4. And so now I need to think about what I actually added over here. This 4 would be distributed, so I added a 9 inside parentheses, but I added a 36 to that entire side. Because it's not just a 9, it's a 9 times 4. This second piece is pretty easy. It's clearly just a plus 4, so I add a 4 to the other side as well. And now I simplify this thing. This guy factors into an x minus 3 squared. This one factors into the y plus 2 squared. Over here, I just add all these together. Looks like it gives me a 16. And now the last thing I have to do is get a 1 over here, so I'm going to divide each side by the 16. When I do that, I just divide each of these by the 16. The 4 over 16 reduces to a 1 over 4. So I get the x minus 3 squared over 4. Right here, this is a 1 divided by 16, so this one doesn't change. It stays as a y plus 2 squared over 16. Again, I'm just using my distributive property and dividing each. Equals the 1. And then the last thing I check is to see if my first denominator is larger than my second denominator. And in this one, it's not. So what I have to do is I have to rewrite this addition in a different order. In other words, I have to flip these two fractions and write it as a y plus 2 squared over 16 plus an x minus 3 squared over the 4 equals the 1. Now it's written in the appropriate format. Now I can see that this is a vertical ellipse instead of a horizontal ellipse. Okay?